Hello. Welcome, guys. Welcome to the session, Accelerate Grid Control System Upgrades using AWS and Evergreen Testing. I'm Farnaz Amin. I lead business development for grid modernization for AWS for energy and utilities. And I work with customers and partners globally to help accelerate grid innovation using cloud technologies. I'm joined here today with Sean Moser from GE Vernova and Jim Liero from PPL. Thank you guys for joining us. So before we start, let's take a quick look at what we're going to cover over the next hour here. I will talk a little bit more about the energy industry to give you a little bit more context, talk about who we are at AWS for energy and utilities and how we're helping customers solve some industry-specific challenges. And then I will introduce the concept of hybrid cloud. Sean will then talk about the challenges that GE Vernova and their customers are seeing in the energy industry today and the solution that they've developed to address those challenges. And then Jim is going to talk more about how they've implemented this particular solution, what their experience has been like, and what benefits they're seeing from this particular project. We thank you again for joining us. To give you a little bit more context around the energy industry so that you can understand the magnitude of the problem that we're trying to solve here today. The energy industry is undergoing massive change right now, and there's multiple different levers that are playing to that change that is ongoing right now. One is the decarbonization of supply. So with all of the renewables coming online, with the share of renewables within the overall energy mix rapidly increasing, right now it's 30%, but by 2030 it's expected to be up to 50% of the overall energy mix. And so that itself brings certain challenges because of the nature of renewables. But there's also the fact that a lot of renewables and storage projects are waiting for interconnection onto the grid globally. Within the US alone, that amounts to 1,000 gigawatts of renewables and up to 400 gigawatts of storage that are just waiting interconnection. And that is because of a couple of reasons. It might be due to just the interconnection processes taking years right now, or challenges with permitting, or the fact that the transmission grid is really congested and cannot take in more renewables. So there's challenges on that side. When we think about demand, at the same time while we're doing this decarbonization of supply, on the demand side, the electricity consumption and the demand for electricity is rapidly increasing. Previously, we've seen like a flat demand curve, but now we're seeing more and more increase in that demand, which is driven not only by the needs of emerging economies, but by electrification of industries, by electrification of buildings, of transportation. And also, more recently, now we're seeing a lot of demand due to AI data centers and crypto. So AI data centers, crypto, they're set to double their demand by 2026. And in 2026, that demand, that consumption is going to be equivalent of the consumption, electricity consumption by all of Japan. So just to give you an idea of the magnitude. There's also decentralization, which is, one part of the mix of the changes that are happening. And decentralization is happening due to the rise of distributed energy resources like rooftop solar, batteries in people's homes, EVs, as well as the fact that, customers are now becoming more and more involved in how they consume electricity. They want to have a choice in the kind of electricity, clean electricity that they're consuming. They want to be able to contribute back to the grid. They want to be very much more involved and updated, and just because of the nature of everything that's happening around the industry. So all of these changes together are putting a lot of pressure on the grid, on the electrical networks, to operate in a way that they haven't previously operated. And they're having to absorb all these renewables, but also map the supply to demand and accommodate all of these changes, but still operate reliably, affordably for the end customers. Jim, did you have anything more to add on, the changes and the challenges that we're seeing in the industry from your perspective?
Yeah, so the changes that we see, they're happening very fast, right? And for a utility, we have to be able to move with that speed, right? So in the traditional, and we'll get into this a little bit later as we go through the slides, but the pain of that is normally I'm on a 3 to 5 year upgrade cycle to try to get something in place that will allow me to now deal with whatever that pain point is, right? And as we go through the slides here and the rest of the talk, we're going to talk about how we're accelerating that so that way we can move faster and move quicker to alleviate those pain points that we're seeing of having all of this different diversified energy come onto the grid.
Thanks. So how is AWS helping customers solve these challenges? How are we organizing? So within AWS, we have a dedicated business unit called AWS for Energy and Utilities that I'm part of, which is focused on solving the unique challenges of customers within the energy and utilities space. We operate at the intersection of energy expertise. So we have like more than 400 energy experts that are part of this team. We also have a lot of technology knowledge and cloud expertise. So we kind of have both of those, and that allows us to bridge the gap between our customers' problems and then the technology solutions that can really help those problems. As part of this business group, we also provide customers with industry-specific solutions, guidances on how to use technology to address their challenges. We help customers with security and compliance, which is a big topic, for the energy industry. We also help our customers with their data strategy, so really looking at the foundational challenges and how they can have their data organized to be able to solve some of these other challenges that are more on top. And then in addition to that, we have a large partner network, a community of partners that can help our customers with some of these challenges, and also just best practices across all of these partners that are using AWS to build these solutions. So if you guys saw the keynote yesterday by Matt Garman, he talked about the financial services customers that had once told AWS that they will never put their workloads on cloud in production for many reasons, such as security, compliance to regulation, or latency requirements. And over a decade, AWS has worked with these customers to address each of these concerns. And now, today, most of those financial services companies are customers of AWS and are using cloud for production workloads. And so energy industry is quite similar in the sense that there is a need for high security. It's very heavily regulated, so there is compliance to regulation that needs to be built into the solution. And so while customers in the utility space are using cloud for a lot of different workloads, but there might be some workloads that may not be easy to migrate to the cloud today. And this might be because of regulation, or it might be that these workloads are integrating with applications that are real-time, have single-digit millisecond latency requirements, or they have used for some local data sets. So there might be multiple reasons why some workloads might not be able to migrate to the cloud today. And in such situations, AWS Hybrid Cloud provides a consistent AWS experience wherever the customers need it. Let it be on-prem, let it be in the cloud, or let it be at the edge. So AWS Hybrid Cloud essentially refers to a cloud computing environment that combines the on-premises infrastructure with AWS public cloud services, as well as AWS edge services such as Outposts. NERC, which is one of the North America Electric Reliability Corporation, which is one of the regulators, has actually written a white paper that talks about how utilities can look at these systems like EMS, these real-time systems, energy management system for transmission, and really looking at that by segmenting it in components based on criticality. So to be able to integrate cloud technologies. So keeping the real-time critical systems on-prem while leveraging the cloud for advanced analytics, for historical data usage, for visualization, for other analytics. So to be able to really balance the benefits of cloud technologies while still complying to regulations for critical grid operations. And so that really speaks to the benefits and the need for hybrid cloud in such situations. The benefits of hybrid cloud, as we mentioned, in addition to the compliance to regulation, is also that it allows customers to move at a pace that they're comfortable with. So really modernize at a pace that they're comfortable with. But also one important other piece is around disaster recovery and backups. So given everything that's happening right now, as you've heard, like climate change scenarios, a lot of outages, a lot of these events really are forcing utilities to look at their disaster recovery options, and hybrid cloud can provide such an option so that grids can continue to operate reliably. What is really driving the adoption of hybrid cloud? So in addition to the workloads that I mentioned that need low latency, have data residency requirements, or have local data processing needs, in addition to that, there's also a need to have a consistent infrastructure, service availability, and performance across the enterprise, wherever it's needed. So for instance, so that the developers that are developing applications can develop it once and then deploy it across the board consistently with the same experience. And that's for the build side. But there's also the need for that on the deployment and the management and the support side. And that's something that we're going to talk about a lot more deeper in the session today. So having that simplified infrastructure, deployment and management that minimizes operational risk, it minimizes downtime, and it minimizes the time and resources spent on management and support. And so this is a good segue into me asking Sean to talk about how GE Vernova is really innovating in this specific space.
Thanks, Farnaz. Okay, so first, thank you guys for coming. Appreciate you guys choosing this session. How many people here actually have utility experience or know anything about utilities? We got 1, 2, okay, a handful. So the thing that's really interesting is in the utility sector, you're basically talking about managing a network, just like any other network. So those of you who are familiar with other networks, think that, right? Availability, security, optimizing capacity, and resilience. There's a safety factor as well. But the challenge is all of the stuff that Farnaz just talked about, to the point that Jim made, is happening really fast. This is the most dynamic period, potentially, that utilities have experienced ever. We're just talking about massive amounts of change, where the electrons come from, where they go to, the demand, and so on. So in addition to now variable generation and an old network in the middle, you also have these massive loads. So one of the things you guys have heard a lot about is AI here at this event. AI actually is potentially the largest commercial load, centralized commercial load that we've seen. We've now got AI data center requests that are basically larger than the generation capacity of the region they're trying to put the data center. So hey, we want to put a data center here to do AI. We need more power than actually exists in this location. So that is a completely different challenge entirely. So when you start looking at all these things, the big issue we've got is speed. And how do you solve those problems? So you need kind of new tools, and then you need those tools to be able to get to the utilities much faster than they're used to. So we'll talk about that a little bit. One, this flex in the operating environment. Just looking like at the far left, that's the AI load. Just AI. The amount of load that is being requested for fueling this new capability is massive. But then you look at where the generation's going. So the generation used to be very waterfall. If you aren't used to utilities, you had bulk generation that was a dam, it was a nuclear plant, it was a big gas plant, it was something. That went over big tall wires, then it went down to little short wires, and then it made it to a destination. And it was very predictable, like just cascaded all the way through the system. But now you've got generation moving to that distribution network. That's a problem because the transmission network, the big tall wires, highly redundant. The distribution network, not redundant. So you've got a network that's not used to actually having load go upstream, that's actually going to have most of the generation capacity as we kind of keep evolving this thing. And then you look at the impacts that are trying to take that grid down. Cyber, storms, those sorts of things, those are going up in a non-linear way. So all of these forces are things that we expect utilities to just deal with. Just figure it out, keep the lights on. It's like magic, right? You flip the switch, lights come on, that happens every single time. Basically magic. We expect them to do that in this highly dynamic, highly transformative operating envelope that they're now living in. So GE Vernova is basically a new spin out from the company that invented the grid, that built the first one. That company is purpose-built for helping electrify the world. Within that, we make software. That software helps manage the grid. Now, we talk about the grid like it's a single network. It's not a single network. The grid is actually a bunch of parts that loosely couple. So for example, that AI load that I was talking about, that's all the way up at the top here in this kind of C&I space, this commercial and industrial space. Then I've got the distribution network. That's where all of us live. Our homes, our businesses, they all connect to that. We've got the transmission network. We've got bulk generation. We've got distributed generation. We've got batteries. We've got cars rolling around. We've got all this stuff that's moving around in this operating environment. We make software that lives in all these places. We make software that lives in the control room. We make software that lives in the network embedded. And then we make software that lives out at the edge. And our utility partners, they deploy that software everywhere. They have to manage all of that to keep the grid available and secure, okay? And so Jim's going to walk us through like what that feels like from a utility perspective. But what we did was we said, okay, all of this software we built for the last 30 years isn't going to work. It's not built to do this. It's highly siloed, monolithic. It's built to manage some part of this. Each one of these actually had a different framework for management, but that can't work anymore. So we came up with this new idea. We called it GridOS, but it's basically a modular, composable, modern, just like you'd see in any other industry, we're bringing that to utilities. That software is a big difference. It's AI-based, it's cloud architected, it's got all of the things that we need to move fast. But the biggest problem was, how does somebody like Jim and his team actually consume it fast? Because what he was talking about earlier is something like this. So they go through, hey, let's spend 1 to 3 years deploying the software. Since we spent so much time getting it deployed, let's not touch it for a while. Then let's do that again. And the upgrade was generally as expensive as the initial deployment. It was just a very painful process. You can't be agile in this model. It just doesn't work. So as part of this new strategy, we also went to something that you all are also probably very familiar with, a much more frequent delivery model. Now that's great. We release at much tighter intervals. We drop, new features, new functions. Instead of big monoliths, you get little bites and you keep evolving the software as you go. Great. How do they take that? They're not used to that, right? That's not a model that a utility is used to consuming on. So we had to deploy a whole new paradigm. We call it evergreen, but it's basically based on an A, B, C, D, or blue-green kind of model where we have a cloud instance, we have a software factory that moves into a cloud instance, it's validated for that customer reference, then it goes to an on-premise instance, and then it goes into production, right? So we have this flow that works through. The idea was to take this 3 to 5 year kind of delivery frequency and this 18 to 36 month actual tack time and get that down to something that was less than 3 months, where they could do this, or monthly if, right, they chose to, but get this to where it's very, very tight cycles. So, and if we could do that, then we could also get much better feedback loops. So actually the product becomes better, the experience becomes better, everything becomes better. So they're getting new functionality that they can deal with this very rapidly emerging and changing and dynamic universe that they're living in. And they get the software better, it's higher quality, they get more input, all of those other really, really good things that you get with a modern kind of deployment model. Now, to do that, we needed a whole bunch of new stuff. GE had to change how we did it. The customers had to change how they did it. And so we had to invent effectively new tooling, new process, new platforms that allowed us to do all those things. So we got to work doing that. And we partnered tightly with AWS to build these things, right? So we're consuming Amazon technology. We're using our own expertise and experience from the rest of the universe. There's other industries that have done this before. Finance has done this before. Defense has done this before. Telco has done this before. We just need to do it here, right? So that's basically what we were doing. And as we keep kind of pushing this out, the way this looks for a customer is effectively we've got a factory of assets, a composable set of assets. We build that cloud instance, and then we can migrate that through. And there's opportunities even to leverage the cloud architecture on-premise to go all the way to something like Outpost here, which we're also testing with this customer. So I think there's a lot of goodness in here. Is there anything you wanted to add to this? Yeah, absolutely.
Yeah. One more. All right. So let me just give everybody kind of the real world explanation on this slide, what we've seen, because we've been doing the evergreen now for quite some time. We've had a lot of success, and we've kind of really vetted through this process, right? So really the concept here for me is I'm moving from projects to pipelines, right? I want everything just to come flowing through to me. I want to get out of that top big project, big bang, forklift, goes away, right? The advantage to that is even something that GE does for another utility, if they put that in and it's going to go into the standard product, I get it immediately then as soon as it goes to production because I'm on the fast track with it coming through on the bottom there, getting a monthly load. What we do is in our CRE, the customer, the purple or the pinkish box there in the middle. So our model sits in there, right? And we'll get into this a little deeper on a slide, but my model sits there with my config, okay? When they have something released, they drop it from their factory, comes out of engineering. Actually, we move our model up one more layer in the evergreen, in the cloud environment, so they can get some real world engineering. Their engineers can test on a real utility model and vet out bugs and problems like that much sooner. Then we get it into our CRE. What I asked in that environment is, I'm gonna use some GE terminology, they have a concept like when I get this in a normal project, they would configure it with what they call Fantasy Island, config and model. That's just standard stock out of the box stuff, right? Now from there, I would start to configure it, how the application, however I want to have the configurations, plus I have to get my model to work on there. All of that is extremely time consuming, right? A lot of trial and error, a lot of trying to figure it out, and then we end up saying, hey, this isn't working, and then we do a lot of this because it's, hey, it's a config, GE tells me it's a config problem, I'm saying it's a bug problem, right? And we go round and round for a little while, and then eventually we iron it out. All of that is just time ticking away, right? And we want to move fast. So what we've asked for in that CRE environment is basically a Fantasy Island model and config. So basically GE stock out of the box setup.
Like a vanilla, standard vanilla kind of model.
Right. They can do their testing on that. If they see any problem there, it goes back to their engineering. Then I ask, okay, can you spin up another instance of this where you're using the standard config with my model? Now, if there's a problem, we know it's not the config problem, it's that the product isn't accepting what's going on there from a model standpoint. Then we do my model, my config. So it kind of allows me to validate that. And the beauty of this is they can spin these environments up super fast. So we spin one up, we do some testing, spin it down, spin up the next one, spin it down, spin it up, right? Real quick. We've already had a success here where we had the GE team, because they're doing testing on their own before they give it to us to say that, hey, it's ready and you guys can go ahead and now do your testing. They came to us and said, hey, just want to let you know, doing all of that, we did find a bug. We identified it as a bug. We took it back to engineering, and this is part of that feedback loop, the rapid feedback in the green. They took it back to engineering. Engineering fixed that, came back into our environment a month later. So real quick turnaround on that, where before in a normal project, we would find that, figure it out, have to go to GE, it goes into their product cycle. It's months until I get that fixed, right? Now the whole time I'm sitting there on that version that I'm locked on. In the evergreen, I'm just moving to the next iteration of the product. So I'm not locked, I'm just waiting and moving along. So when that bug comes, I'll take it in the next release, and then I continue my testing. So we've had a lot of success with this already in terms of finding issues, rapid feedback loop like Sean described, and then running that back around. So a lot of, this has really been very powerful for us.
Yeah, and it's been great for the development process as well, because again, remember, this is a completely new architecture for this industry, completely new products. We're reinventing the things that we've already been doing for the last 30 or 40 years. So that it helps us do this faster, it helps a customer build confidence faster, and it does help us with the consumption model, right? They're able to consume these things as fast as we can qualify them and release them, which is also uniquely challenging in this industry because of the amount of regulation on the configured environments. The amount of regulation around that control software is quite high. So ideally, we'll continue to tighten this up and we'll get to where it's even faster. But right now, the amount of process that you have to do, this is actually it's a logarithmic change. It's like a massive amount of progression here in terms of timescale. Yep. So what this, in terms of AWS, then if you say, okay, great, so I've got all of this capability and I'm building all of this as cloud architected and so on, what are we actually using in here? So the things that are actually in here, so for a customer, this is what it tends to look like, right? So we have our software toolkit, so you can see we've got a whole bunch of things in there. We've got Kubernetes in there and Argo in there and a whole bunch of other stuff in there that are all things that are built within our products and solutions. Then we're exposing that effectively to merge in the customer's configuration, the customer's data, and merging that into the software environment. And then we're using AppStream to let the customer just go in and run that environment, test in that environment. So we're automating the deployment of all of this. So the full package and deployment all gets automated. It gets, as Jim said, we can redo this over and over and over again, as you would expect, right? I mean, this is not sort of new. This is just new here. And it is interesting in this environment because we are having to do things, we're having to add a little bit, right? We take what was already done and we've added the regulatory requirements for utilities because you've got safety and you've got to keep the lights on and all sorts of other things. So you can't just sort of rapidly deploy things that aren't qualified. In here, we're using a whole lot of AWS services. And we'll continue to evaluate more and more AWS services, but these help us. The partnership with AWS has helped us accelerate this and do this in a much quicker pace. Now we can break over, and Jim, you want to walk us through what this actually looks like in PPL.
Yep, I'll take it from there then. Right, thanks, Sean. All right, so we've talked about, the AWS, the environment, the evergreen, and the delivery pipeline. What you're looking at here is basically our ADMS, which is our Advanced Distribution Management System, right, for controlling the distribution grid. Application is extremely complicated. We have a whole lot of different servers, a whole lot of different internal applications that run, Power Apps that are running in there, all types of stuff. What the intent of in our CRE is to mirror our production environment as closely as possible, right? We want to make sure that everything looks the same all the way up and down. So on the bottom, on the servers and the white boxes, so this system is multi-node redundant, right? So we have primary backup data centers, right, for all that resiliency that we have. There's 4 nodes. We have an A and a B in one. We have a C and a D in the other, and you can see the servers on here. We have all of the Power Apps sitting on top of that, and this is all configured within our CRE. So as G's releasing things, putting them out, they're coming in here. One of the things that we can do is then, as we spin this up, we can go through and do our full testing. So we can do failover testing. So we can sit there and watch it, and we can say, okay, we're going to remove the A node, and we're going to watch that come down. B's the primary. We watch B come up. C and D behave correctly, and then they come up as the alternates on the other end, right? We can simulate failing out an entire data center going down, and we lose the A and the B go down, and we watch the system fail over to the other side, right? So we can do all of this super quick in that environment to fully test. Our intent is to move all of our normal testing that we would do on an on-prem environment up into this cloud environment. That includes our integrations, right? And everybody gets kind of scared where they're like, integrations, you can't test those in a cloud environment. But we know what the goes outs of these are, right? And we know where they land on the middleware. So if we know what the goes out is, we know what the goes in is, we should be able to match that up. So we want to test as far out as we can in this environment to that handshake so we can be totally vetted up there. The more that I can find in this environment, I can feed it back to Sean, they feed it back to their engineering folks, and the cycle just comes right back around like I described earlier, and we have things fixed and up and running. So that's kind of our intent where we want to push everything up. This mirrors our prod environment. right? Because again, we want to replicate everything we're doing up there. Because when we bring it down, we don't want to do anything different. We want it to be the same. That way we know that we've vetted it all the way through. And a lot of the tools that Sean was talking about, like, we're using Jenkins and pipelines like that and things to deploy and move it along. So we're using all the modern stuff. The other interesting thing here is Sean talked about Grid OS, right? So as they're on their journey to modernize their tech stack and change that out and bring that up to speed and release new features and things like that. And a lot of that goes into those teal boxes, okay? So as they're releasing that, this gives me the ability to say, okay, I want to have a legacy spun up version of the product sitting there, and then I want to spin up another version that's the new Grid OS. As they're releasing it, I can put it right into my environment. For me, this is my fast track to get my whole system over to Grid OS, because as they're releasing parts and pieces, I can just plug and play them in. If they work and they behave nicely with everything, I can pull them down to my prod environment. If they don't, I can say, hey, I'll just wait for the next piece to come along. I'll grab that now and then bring that down into my environment. So it really gives me that flexibility to move quickly and bring it along and deploy what I need when I need it as we need to go. Same thing, really ideally for me, it's even an innovative test lab. So like if I'm like, hey, Sean, I'm seeing this is my problem. This is my new pain point on the grid. I need to deal with these batteries, for example. They're really, giving me trouble. I have to control them. I have to see them. I have to do X, Y, Z with them, right? We come up with an idea. They hatch it out, drop it in my CRE. I can test it on my real world model. We can see what's happening, make sure that's working correctly, and then move that into our production environment. So again, it's all around being nimble, being quick, kind of more reacting faster to what I'm seeing on my grid, where normally, on a normal situation, I'm gonna take, months of development for that, right? It takes too long to get that out for us. The other part here is, what was I going to say on that? We have interfaces that go over, eventually we want to move our energy management system, our EMS for transmission into this environment. That'll be step 2. We have to fight a little bit more of the SIP battle there, if anybody knows what that is. There is a thing called SIP jail. I don't want to go there. Once we have both of our control systems in here, then we can test everything, how they play together, because we have a lot of integration between those. So one's getting information from the other and data's moving back and forth. Then we have our whole environment here and we can test that back and forth. Basically what I'd like to see is my entire GE ecosystem lives inside of this domain. As it comes down, that way all of the integrations between the applications that I own from GE, they're all tested all the time. If they change one piece, it all has to be tested together. So everything kind of gives me that extra reliability to bring this along and bring it down. Vernova talked about the Outpost. So that's kind of our next thing that we're talking with both AWS and GE about is Outposts. So we're doing a POC with them right now to look at a hybrid Outpost where they're going to take the model because they already have it here in this environment. We can move that out and we can say, okay, let's try to do this with a hybrid like on-prem Outpost rack and then a cloud Outpost rack, and then see how those work back and forth. So we're trying to push that now as well to validate that and vet that out. Just a quick note too on our model. The model is obfuscated, so all of our pertinent customer information and anything like that we deem as too high to let out, we've obfuscated that data and that's all been removed from this, just for everyone's awareness as well.
Let me add a little bit too, because I think the thing, especially for people who aren't from the utility sector, the thing that Jim's trying to solve for and that we're all trying to support and help with is utilities are used to rolling all this stuff themselves. And so all these environments are basically snowflakes. They customize the data model for no real reason. They have their own way they want to label things and call things, and so they create their own unique variant of a model that's basically the exact same stuff as the neighbor utility has, but they describe it all a different way. They customize the configurations. They customize the deployment model. They They put different pieces of software in different places. This goes here, this goes there, that goes next to it, that goes somewhere else. All completely unique. Literally every utility, totally unique. And not really that valuable to be unique. And they're not competitive. Like, these utilities don't compete with each other, they're friends. So there's no reason for this except that it's just always kind of been that way. And so one of the other things we're trying to solve for is how do you actually stamp out variance? How do you make this to where they're not a system integrator, they're a grid operator, right? And they're focused on providing service to the millions of constituents that they have that need electricity every day, instead of how to cobble together a bunch of software and hold it together and make it work every day. So what we're doing here with PPL that's so unique is these are standard configs. This is basically GE tested, GE designed, PPL validated, PPL deployed, and all the way through. And Outposts is just an extension of that. It's basically appliancizing the whole thing and just stamping it exactly on premise, exactly how it is in this customer reference environment in the cloud. So it allows us to basically, by extending, effectively having a VPC, we can just kind of move the software through this whole value pipeline of test and validation all the way into production really seamlessly.
Yep. All right, we talked a little bit about how fast they deploy this, right? So this is the deployment times here, a little bit of what we're looking at. So all total here, you're roughly looking at maybe about, 7 to 8 hours it takes to spin this up. Normally when we do a deployment, it takes us, now some of that's our own slowness because we want to be a little cautious, but it'll take us a weekend to do this, right? Day one, we do, an entire day to get this deployed and up and running. So you can see here, like, you're saving a lot of time on just this. So if I'm like, hey, I need to have my environment up, I want to do some testing on something, right? They can spin it up for me, kick this off. It's all containerized in a Jenkins deployment. So it's literally push the button, off it runs. They can pick which script they want to run. I can have different versions of the application. I can go back one. I can stay on the latest one. It's really up to me. I can configure this however I want to do it. They can have it set to kick off, or they can kick it off for us. They'll spin it up. Ideally, we'll want to learn to kick it off ourselves. So if we want to spin this up, we can spin it up on our own. But really, in our AWS environment, we're spinning this up and down, right? Because obviously, we don't want to just sit there and have it spinning all the time. That's just killing us, right, at that point. So we spin it up, test, and go from there, right? So that gives us it gives you a little bit of an idea how fast this is moving. It's really pretty quick.
And PPL's good at this, by the way. Other utilities, this is not 2 days, it's 4 or 5, right? Where it's days to do something that shouldn't be days, right. But it is. So
right. Now, if you're thinking about that in a regular project environment, right? I'm going to have, we're going to start the project, we're going to get it, we're going to have to deploy it into a dev environment, we've got to deploy it into a QA environment. Eventually, we'll go to our prod environment. Through the course of that project, we're going to get some kits from GE. Every time we get a kit, we got to go through the whole process, starts all over again. We got to figure out how to deploy it, get it deployed, go through all that, go through the testing all the time, right? So it's this evolution through a project that's time consuming. And this is just speeding that up, where I can just, as soon as they get it, they can spin it up, I can start testing and go from there. Speaking of testing, so test automation here is the key, right? So, you can spin these things up as fast as you want to go, but if we're not automating our testing, you're still like stuck in neutral a little bit, right? So the big thing here is test automation. So we've worked on, and this is the phase of this project where we're at right now. So we're kind of in this evolution of this process right now. What does this look like? But our intent is, GE has their test scripts. They're going to test those. We have our test scripts. We're going to continue to deliver. Part of our agreement with GE is we deliver them our test scripts, and we come up with more test scripts to deliver to them, and then they're going to get automated. So basically, we can run our whole barrage of testing automated, spin it up, kick off the testing, run through, see what failed, poke into that, and then go from there. And ideally, GE is doing this before my folks are even touching it, right? It's kind of like They're running all the scripts, doing all the testing, kind of giving it the blessing and saying, okay, from our view, this is good to go. PPL, you can go in now and really kick the tires, and is this behaving the way you expect it to behave, right? And then we would go in and do our testing. And a lot of the final testing that we're doing is also then kind of that operator experience, right? Where you're actually sitting there, you click the control box, it pops up, you're really kind of getting the drive the car, if you will, and does it behave like I'm expecting it to behave? And that would be kind of our final testing.
And this process, again, is usually the long pole for most utilities. Utilities will spend days or weeks doing testing just to make sure that they've really have high comfort. So anything that we can automate and provide the validated output early allows them to kind of move forward quicker. So this acceptance testing process is really critical to crush down. And we're talking about now going from weeks to minutes and hours in this cycle.
Right.
There's also the skill gap sort of angle to this as well, right? In terms of like utilities and their cloud and software teams, they have cloud engineering, they have engineers that are familiar with GE software. There is sometimes skills gaps that exist in those teams to be able to do all of these different things, whereas having a consistent tech stack, whether it's on-prem, in the cloud, on the edge, really helps utilities address those skills gaps as well and train those employees to the right skills that are needed to be able to perform this job, and really simplifies the whole overall process as you guys have described it.
Yep. Yep. Now, part of the automation here is, in the end, is we want to be able, we need to get, we have our model, we need to give them, and we update our model monthly. So we need to get that model back up to GE as well. So right now in our process, so we're going through our processes and we're saying, okay, in this new world, what would we do, right? How do I make sure that my CRE environment stays in sync with my production environment? So right now we're looking at just adding to our process when we do our load to our production environment and we change the model. We just take that model with the config, we send it up to the GE team, they load it into the CRE. So, and there's a little bit more work there that we need to figure out on how does that work, what does that look like? Right now we're giving files and landing them in zones and all that, but ideally, right, we want this to be like, a pipeline where everything's just constantly moving along. I think that's an opportunity where with the Outpost and having a rack, if I have a rack in my environment, sitting like in my on-prem data center, now it's just an easier because I can just drop it on there. They can pull it across. When they're done and we're happy on the CRE, we just pull that down. It goes right into my environment, right? So it's a little bit more kind of drag and drop. I'll describe it that way, is the feeling that I would shoot for there, where you're just pulling it down and dropping it on. And it's a much easier transition to go from one to the other. Instead of right now, it's a little bit of, we got to kind of jump some walls and move it around. But ideally, it's as seamless as we can make it. I'll turn it back over to you, Sean.
Well, yeah, I think the net here at the end is look at what we're trying to accomplish is we're trying to enable utilities to keep pace with the pace of change that they're facing right now. And we're building software that helps them do that. So, having software that is now delivering 21% less outages than anybody else's software, 17% faster recovery times than any other tools that are available in the market today, or allowing up to 70% penetration of renewables or 40% lower cost on managing that, that's great, but not if the utility can't consume it, not if they can't actually deploy it. And so also reducing the install times by 92% or the test times by 96%, that enables utilities to actually consume this technology and deploy it against the problems that they're now facing. Because at the end of the day, we all expect to be able to walk into a room, flip a switch, and the light comes on. And it needs to stay magic. Like, that needs to just happen. And so that's our mission, is to enable utilities like PPL to keep doing that. And AWS is a fantastic partner in helping us help them. So thank you guys for the partnership and the help, and thank you all for coming.
Thank you, guys.
Thank you.